So in this lesson, we're doing the identifying proportional relationships. So we're identifying proportional relationships in graphs and in tables. So first I have a graph here on the coordinate plane. And it says which ordered pair would form a proportional relationship with the point graphed below. So if you remember, a proportional relationship on a graph must be a straight line. So right here, I do see a straight line. And it has to go through 0, 0. So I have 0, 0. Awesome, it meets both, so I know it is proportional. So I'm looking at all 4 of these points. I want to know which one could I plot and it would form a proportional relationship. And I can simply do something like this. Look at the point they give you right here, -40, -10. So in order for me to find the constant of proportionality, I can just divide. -40 divided by -10 gives me 4. Y divided by x, which is y is -40, x is -10. 40 divided by 10, 4. So I'm going to look at all of these other ones and say y divided by x, which one give me 4? 10 divided by 40, well, that gives me 0.25, so that's not correct. -10 divided by -5, well, that gives me 2, not correct. 20 divided by 5, well, that gives me 4. They match the same thing. They have the same constant and proportionality, so C would be the correct answer. And just because D is not the correct answer, because -20 divided by -10 would give me 2. So 40 divided by 10 is 4. 20 divided by 5 is 4. So they both work. And if I were to plot 5, 20, remember I'd go over 5, up 20. It actually falls on that blue line right there. So I know that's part of the line, part of the proportional relationship. I'm going down right here just real quick. And I have some of the same thing right here. This case, it doesn't give you a line, but it says which ordered pair would form a proportional relationship with the point graphed below. So they give me the point right here, -20, 40. So we'll do the same thing as we did above. Y divided by x. 40 divided by 20, that's going to give me 2. So I'm going to do all of these right here, y divided by x, and see which one gives me 2. 20 divided by 40, well, that gives me 1/2 or 0.5, not correct. -20 divided by -10, well, that gives me 2, but be careful. 40 divided by -20, a positive divided by a negative would actually get you -2. So we're looking for -2. -20 divided by -10 gives you +2. -30 divided by 15, oh, that gives you -2. -15 divided by 5, that'll give me -3. And another way you could have looked at this, I could have graphed each one of these points and see which one would give me a straight line. A straight line and goes to the origin. -40, 20, I go over 40, up 20. Even though it'd be a straight line, wouldn't go through the origin. -10, -20, I go over 10, down 20. Again, a straight line, but would not go through the origin. 15, -30, I go over 15, down -30, straight line, and would go through the origin. And the last one, 5, -15, I go over 5, down 15. It would be a straight line, but it would just miss the origin, be about right here. So my correct answer would be 15, -30. So if I'm looking at it on a table, I have, again, a graph has to be a straight line and goes to the origin, which is 0, 0. But on a table, it says which table represents a proportional relationship. So for here, I can either find the constant of proportionality, or I can find something that works for every section of that table. So for example, right here, using multiplication or division, how did you turn 5 into 25? Well, you did times 5. So every one of these has to be times 5. 7 times 5, that gives me 35, but this number is 49. Obviously, they're not the same, so I know this one is not correct. Going right here, how did I turn 3 into 6 using multiplication or division? 3 times 2 gives me 6. So I need to see if times 2 works for all of them. 8 times 2 does not give me 11, so I know that one's not correct. And my last one, again using multiplication or division, 6 divided by 2 is going to give me 3, so it needs to work for all of them. 10 divided by 2 gets me 5, that works. 14 divided by 2 gets me 7, that works. So this table right here represents a proportional relationship because it works for every single one. The same operation works for every single one. Right here it says if the relationship is proportional, what is the missing value? So I can do a few things here. I can either go what I did up here, I can go 8 into 6. That's going to give you some decimals and fractions, and that's okay if you want to do it. But I can also use go vertically. So I can say, okay, how do I turn 8 into 16? I multiplied by 2. So I did the first number times 2 gets me the second. So I did the exact same thing right here. 6 times 2. I know my number in question would be 12. Last example right here, just how we did. I have my x and y's, and I'm looking for a relationship that is proportional. So I can say, okay, well, 12 times 5 will get me 60. So if I know 12 times 5 gets me 60, 15 times 5 gets me 75. So I can 180 times 5. So I'm going to go over here, 180 times 5. Let's see, 0, 0, carry the 4, 5, 6, 7, 8, 9. 900. I know that number in question is 900. Another way you could have done this, 12 times 15 is 180. 60 times 15 is 900. So you can either went vertically or horizontally. It doesn't matter which way you go, as long as you're doing it. If you're doing vertically, you're doing it for both. If you're doing horizontally, you're doing it for both. And that's identifying proportional relationships on tables and on graphs.